Using the substitution u is equal to 4x minus 3 or otherwise, show that the integral from 2 to 5 of 2x over 4x minus 3 dx is equal to 3/8 times a plus ln of b over c, where a, b and c are positive integers, which we'll need to find. Okay, we're given the advice to use substitution, so we'll go with that. So you could do it by other means. So if you let u be equal to 4x minus 3 as suggested, you have to differentiate the substitution. So du by dx is 4. And because we're going to have to replace dx, we have to make dx is equal to du over 4. The x will not cancel out, so we'll need to get a value of for x in terms of u. So if we rearrange this, you add 3 to u and then divide by 4. We will also need to change the limit. So when x is equal to 2, we'll do 4 times 2 minus 3, which will give me 5. And then when x is equal to 5, we'll do 4 times 5, which is 20, minus 3, which will give me 17. Right, so our new integral will be from 5 to 17 of 2 times x, that's 2 times that, over u, because it's 4x minus 3, times du over 4. Right, the 2 and the 4 will cancel, you get a 2. And combined with that 4 there, that will make it 1/8. So this integral will now become u, 5 from 5 to 17, u plus 3 over u du. And then what we'll need to do, u divided by u will just give me 1, and then we'll just get plus 3 over u. So we're going to get 1 plus 3 over u du. And now we can integrate it. So we've got 1/8 of the integral of 1 with respect to u, which is u. And then 3 over u will give us 3 ln of u. And then the limits have to go here. So carrying that on, if we put the limits in, we get 1/8 of 17 plus 3 ln of u plus minus 5, and then minus, it'll be minus 3 ln of 5. Don't forget to change this sign here. So we get 1/8 of 12, 17 minus 5, and then because we've got 3 in front, we can write this as plus 3 ln of 17 over 5. So I found my b and my c. There's a common factor here of 3. You need to make sure you write it in the right format. So it will become 3/8 of 4 plus ln of 17 over 5. And we now have the correct format as required by the question. So this has been a video to show you how to do an integration by substitution. I hope you've understood, and I thank you very much for watching.